Hello, so in this class today we will study about the IPv4 datagram format. So we have studied over here about the network layers, the requirement of your IP address that is just used here for the identification of the various data packets which are transmitted here through the network layer. So packets in IPv4 layer are called as your datagrams because we know that our complete data that is segmented into small packets. So those data packets in your IPv4 layer, that means your network layer, are referred as your datagrams. Now, this is the format how you will have a datagram. So that means basically you have an header and the data. So this header is basically a field which is used for the routing and delivery of your data packet. That means the identification of the destination and also specifying the identity of the source here. And this data here is the user payload. So this complete field here is the range of this field is from 20 to 65,536 bytes. So out of which the length for your header is 20 to 60 bytes, and the remaining is your data. Remaining is your user payload. Now we will study here that what are the various fields which are associated with this header, because this is normally your information, your data. Now we will study about the format of this datagram, or we are concerned here with the format of the header, that what are the various fields which are used here so that the data is, or your packet is transferred from one point to another, from source to destination here. So now we will see here the datagram format. So if like this, header and the data. Now we have various fields here. So we will study each of these fields. So this is the version 4 bits. Then you have the HLEN, which is your header length, then the service field, and then the total length. The next has identification bits, which is also in 16-bit field. Then you have flags and fragmentation offset. Next we have here time to live, which is also called as the TTL field. Then protocols, and then header checksum. Next, source IP address, then destination IP address, and then a last field which is your options. These are your 32-bit fields. Now, very first one, we have the VER, so which is your version. So this is a 4-bit field which basically defines the version of IP, the version of your internet protocol. So that tells that which version is being here run by the in the processing machine, so that the appropriate datagram can be processed here. Now, if you are using IPv4, so this field here will be specifying the version 4. Now, the next field which we have here is the header length. This is header length here. So header length is also 4-bit field, defines the total length of the datagram. This is required because length of this field here is variable. So this is the header length here. Next we have the service. So this field, this 8-bit field basically define here the types of services. So this field is like these three here define the precedence. That means it defines the priority of the datagram in conditions like your congestions. For example, if a router is congested and it needs to discard some of the datagrams, so lowest priority of the datagram which have the lowest priority, they are discarded first here. Now, after this precedence field, it has 4 fields with it. So this D here specifies the minimum delay. This T here specifies maximum throughput. R is here for the reliability and C is the minimum cost here. So this is the service build field here which defines the precedence order for the datagrams and the type of services for your delay, throughput, reliability and cost. Now next field here is the total length. So total length here specifies, this is basically a 16-bit field which defines the total length. It means header plus your data. This is header and your data here. Now next we have identification bits, flags and fragmentation offsets. So these three are related to each other and they are used here for the fragmentation of the data. Now, identification is also, or this purpose of this identification bits is in the fragmentation of your data. Now, what happens? Your datagram travels through different networks. That means different networks will have different format, size, or different sizes of frames, and that here depends upon the protocol which is used by the physical network, like from local area network to wide area network. Now, each of this network, according to their frame format, specifies a maximum transfer unit, which is also called as an MTU, which is a maximum transfer unit. So each protocol has its own frame format and that defines the maximum size of data which could be transmitted through it. So that means the total size of datagram here must be less than the maximum size, because only then it can be transmitted through that network here. So these restrictions are here basically defined by the software and the hardware criteria. So that means if the size is more, you have to fragment the data. Now, when you're fragmenting the data, that means you're dividing it into more smaller packets. Now, at the assembly end, when we have to deliver the data to the user, that has to be assembled again. So that can be assembled again if it has some identification parameter. That means if it one datagram is formatted. So the fragmented packets must have an identification so that they can be assembled at the receiver's end so that it can be transmitted as one data packet to the user. So what happens when your data is fragmented? Each fragment has its own header. That means that fragmented unit, first of all, your data packet has a header, but when it is fragmented, so the fragmented unit here will have its own header with most of the fields repeated. So also during fragmentation, what happens, the most of the header part is copied. So this identification, which is here is a 16-bit field, this is basically a combination of your identification, this fragmentation ID and the source IPv address. This is the combinations because it will specify the source also and then the fragmented data packet also. Now next you have the 3-bit field, which is your flag. Now it has these 3 fields. Now this one is reserved. Now next field is do not fragment. So if its value is set to 1, it means that it should not be fragmented more. Now next field, which is 3, this is more fragmentation bit. So according to that, if it is 1, it means the datagram can be fragmented more. It's not the last fragment, it can be fragmented more. There could be more fragments here. So this is also associated with this fragmentation of your data. Now next what we have here is fragmentation offset. Now when we are fragmenting or dividing our payload into a small number of fragments, so this field, this fragmentation offset, basically shows the relative position of particular fragment with respect to the whole data. That's why it's called an offset, because it's here representing the relative position of the fragment with respect to your complete datagram here. Now, next we have the fields here, like your time to live, which is also called as your TTL. So what happens is time to live basically calculates how much time a datagram requires to go from one machine to another. So this basically specifies here the lifetime of a packet. So what happens when a source host sends the datagram, it stores a number in this field, in this time to live field. So this is approximately 2 times the number of routes. So when it passes through these routes, or we can say that it hops from one router to another, the datagrams decrements that value by 1. So if it reaches the destination within specified routes, the data is successfully transferred. But if it doesn't reach, so the datagram will be discarded here. So this basically here specifies the lifetime of a packet. That means how much hops it required to go from source to the destination here. Now next we have the field which is protocol. So this is also an 8-bit field which basically defines the higher level protocol. So about this field, we can simply say that it specifies the final destination protocol to which your datagram is delivered. It specifies the final destination protocol to which your datagram will be delivered. Next we have the header checksum. So header checksum is used here for detecting errors which might have introduced during the transmission or the storage. Now next we have the source IP address, 32-bit field which defines the IPv address of the 4. Then we have the destination address, again a 32-bit field which defines the destination address. Then we have another field option. So this is not used here for datagram, but it can be used for like debugging and your testing procedures here. So this is the format here for your IPv4 datagram. Now we have IPv6 datagram also, because like your IPv4 is exhausted. So we have another version of your internet protocol, which is your IPv6. Now, internet here must accommodate real-time audio and as well as video transmission. So it requires minimum delay strategies and reservation of certain resources also, so which is not provided here by IPv4. So that is why we have another improved version of your internet protocol, which is your IPv6. More internet unit must accommodate encryption and authentication of data. So the adoption is slow, but that has been adopted in your IPv6. So there are certain advantages of IPv6 over your IPv4 protocol. So first of all, it accommodates resource reservations and minimum delay strategies. Moreover, it has here larger address space as compared to your IPv4. It has here larger address space. So this is basically 128 bits long address here. Next advantage is that it has a better header format here. That means it uses new header format in which options are separated from the base header. That means you can insert certain fields where they are required. So what you have, if you have here like base header and the payload, then you have certain extension headers also which can be used here. So if you just have a look at the diagram or the format of your IPv6, so you have those three fields like a base header and payload, and then your base header you are having these fields. This is the version field, priority field, then you have flow label, payload length, next header, and then hop limit. Then source address and the destination address here. Now this is the same field like we had an IPv4 version which defines the version of IP. Now here is 6 IPv6 field with a value. Next field is a priority. The 4-bit priority field. This is your 4-bit fields. Now this 4-bit priority field defines the priority of packets with respect to the traffic. That means in order to control the congestion, so it is specifying here the priority of the various data grams. Now next we have flow label. So this is basically a 3-bit field. That means it's a 24-bit field here. It provides special handling for the particular flow of data. That means we have a label here for the flow of data. So it's consulting the flow label table, and then according to that the datagrams are forwarded through the network here. Next we have here the payload length. So this payload length is a 2-byte, or you can say 16-bit field, which basically defines the length of the IP datagram. So this specifies here the length of the complete IP datagram. Now next is our field which is called a next header. So this field here is similar to the protocol fields in your IPv4. So it defines the header that follows the, or we can say that the next protocol here. It defines the header for that next protocol which your datagram will be delivered. Next we have the hop limit, which is similar to your TTL field, which is time to live. That means it specifies the lifetime of your packet. Next we have the source address and the destination address of the datagram. Now I talk here about the extension headers. So extension headers here basically includes So these extension headers basically provide greater functionality to your IP. So the extension headers here are like your fragmentation. Whenever it is required, this could be inserted here. After that, source routing. So this basically combines the concept of strict source routing, not the loose source routing. After that, hop by hop option. It is used when the source needs to pass the information to all the routers which have been visited by the datagram. That's why it's called as hop by hop option, because it is forwarding all the information through which it has passed. Now next we have the field which is here in the authentication is the authentication field here. So authentication header has a dual purpose. It validates the message sender and ensures the integrity of the data also. After that, we have here encryption security payload also, which is with ESP, encryption security payload. So this is an extension that provides confidentiality and guards the against the security of your data. That means for the protection of your data against any hostile attackers here. So here we just have said about the IPv4 datagram format and the IPv6 datagram format. So this is all here for today's class. Thank you so much.